Here we are finishing off our lesson about proportional reasoning. In example number 1, Thomas runs at a rate of 4 meters per second. How long will it take him to run a kilometer? And a little reminder about 1 kilometer is 1,000 meters. Okay, so it doesn't state, hey, here's my ratio, but here we are. What are the two things that are being compared here? Well, for every 4 meters that he runs, it takes 1 second. Or for every second that he runs, he goes 4 meters. So that's the ratio. We're comparing how far and how long. And over here, how long will it take him to go 1 kilometer? Well, I could put 1 kilometer up here because that's like how far he goes. But we have a problem here because the units aren't the same. So I guess this would be our unknown down here. So what we need to do is change that kilometer into meters. So our units have to be the same. So I would rewrite this to say 4 meters per second. Per just really means divided by, or a fraction bar. A fraction bar actually means divided by as well. So when you see the per, you can think of as, I'm not stroking it out, I'm thinking of it as a fraction. So we have 4 meters for every 1 second is equal to 1,000 meters times x. Hey, we could probably try our shortcut on this one. If you're up for it, we could think of it this way. We'd have to multiply that times 250. So this one would get multiplied times 250. That would work, and we get an answer of 250 seconds. Or actually, we could go like this. We could say from here to here, we're multiplying times 4. So what times 4 is 1,000? It's 250. Or if you're not comfortable with that, and that's totally fine, oops, we could also just use some algebra, and we could say 4 times x, so 4x is equal to 1,000. Because 1 times 1,000 is 1,000. Divide both sides by 4 to get x by itself, and we get x equals 250. And when you've got the answer, I'm a stickler for this, so make sure you put the units in. And you'll know the right units when you look over here, right? So we've got meters, seconds, and here's our answer, seconds. If you want to, you could even write seconds over here, but I think that makes it a little bit complicated because you see XS and things like that. So your answer is 250 seconds. Looking at example number 2, there are a lot of words here, so we got to, I think, since you know this is going to be a ratio question, then we got to go through all this text and figure out where's the ratio. Okay. Engines that require you to mix oil with fuel to provide lubrication are called two-stroke engines. A faller at a logging site needs to refill a chainsaw's fuel can. The ratio, oh, bing, 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 the ratio of gasoline to oil. You know what, I'm just going to think, okay, it's going to be gas to oil. This is what we're looking for. Is 40 parts of gasoline. I'm even going to write this down, 40 parts of gas to 1 part of oil. What's a part? Well, a part can be anything, but the point is that it's the same. Like if you got 40 milliliters, it would be 1 milliliter. If you got, in this case, I think you do liters, 40 liters to 1 liter. So 40 to 1. So in this case, it's going to say the chainsaw's fuel can holds 8 liters of gasoline. So gasoline is going to be in the numerator. So I'm going to say 8 liters over how much oil should be added to the gasoline. So the oil is going to be X. Okay, and our answer is going to be in liters, right? Parts can be anything. So really, we're all talking about liters. You could even just write this over here like this: 4 over 1 equals 8 over x. And just a reminder, you're going to put liters as your answer. Okay, well, let's do the algebraic method. 40 times x is 40x is equal to 8. We're going to have to divide both sides by 40. So I probably would use my calculator for that. I'm guessing, what is that? That's 2 over 10, so that's 0.2. So I'm going to say x is equal to 0.2 liters. And if you're wise in the ways of liters and milliliters, you'd realize that there are 1,000 milliliters in a liter. So you could say, or 200 milliliters. There's a good answer. We'll get into those kind of switching between units a little bit later. So this is perfectly acceptable, 0.2 liters. Example number 3, Jean-Luc, a builder, has found that he can arrange the work cubicles of his employees best if the ratio between the length and the width of a room is 3 to 2. Okay, so length to width, I'm just going to remind myself, length to width is going to be equal to 3 to 2. So the length is, length is the longer side, right? So 3 is bigger than 2. If a room is 6 meters long, so where do I put the 6? Well, length, 6 meters long, so I'm going to put the 6 meters up here. How wide should the room be? It will be x. Hey, I think this is a pretty good friendly question, isn't it? Can you see what the answer would be? I would have to multiply both sides by 2. So to me, it's pretty clear that it's going to be, the width will be 4. And what are the units? Meters. 4m, 4 meters. I like to put a box around my answer so that the teacher can say, hey, there's the answer. Example number 4. If salmon costs $1.89 for every 100 grams, well, we're going to be setting this up. 189 for 100 grams. How much will it cost? So we're going to be wondering the cost, which is in the numerator on the top of the fraction, to buy 250 grams of salmon. I could go and just say, hey, I'm going to multiply this times 2.5. Multiply this times 2.5. Or I could use my good old algebra method, which would be 189 times 250 is going to be equal to 100x. I'd have to get my calculator out for this one. 472.5 equals 100x. So I need to divide both sides by 100. Perhaps you know the shortcut. If you're going to divide by 100, you just move over 2 decimals because there's 2 zeros in the 100. So I get 4.725 equals x. What are my units for this? X is on the top of the fraction. It's money, it's dollars. So I don't want this many digits. So I need to round this off. So I'm looking at this to the nearest cent. Should I put 472? Or should I put 473? And the answer is we need to do 473. And our rule in math is if the number over is a 5 or greater, then we round up. And if it's less than 5, then we just truncate or take away the 5. So our answer is $4.73. Example number 5. A local pluming store, my goodness, I think it's supposed to be plumbing with a B in there, plumbing store, sells 100 copper-plated pipe straps for $4.97. So it's going to be 100, what are the units for that? Straps, 100 straps for every $4.97. You have estimated that you require 75 straps. Where does the 75 go? Up top. How much would you pay for the 75 straps? We'll put an X over there. I think it's a perfect time for use of algebra here. I'm going to say 100 times X is equal to 497 times 75. Again, I think I got to get my calculator out on this one. And that is 372.75. If I divide by 100, I end up moving the decimal over 2 places, so I get 3.7275. Now this is money again, so if it's money, then looking at this, I want to look at this digit here and say it is 5 or greater, so therefore it is $3.73. We had 2 answers with 73 cents. I've run out of examples, so after this, you've got a little worksheet to work on, and I will see you in class.